Yes, I'm back.
Okay, so we can start. Okay, so we are where we are. We are on baseless expectancy. Okay, so I was just customizing this procedure basically. So my physical memory in KB now. Okay, just need to modify not in that is KB. It's very old procedure basically. So that's why the name is changed and from now it will work. Yeah. So alter procedure name now. Okay, let's see this procedure first. Yeah, okay, got it, all these things. So I have just created this in 2011. Okay, very old, more than 12 years ago. For my dashboard, basically I'm visualizing this data on that reporting using reporting services on dashboard basically. So we see that time, cache hit ratio, total RAM used by total RAM on server. I'm thinking it is converting in TB, I think. Okay, SQL server, procedure cache here. Okay, page life expectancy here, number of connect user connections, deadlock, read write per second, or yeah, so total read write per second, or total connection sessions on the servers. So I've created like this, and we have also about that disk space and all. So I will show this on in 9 day of class. Okay, in full detail. Okay, how can we create and customize this procedure and visualize this report. Okay, it is using all these things. So it will show you in single click from all the servers. We give the list of the servers and all. We can check, and we'll sending that report to the upper management regarding this some servers. Basically, they are ask us to monitor this server very frequently. Okay. So now on that page life expectancy, so we have to enable two features on the Windows side, virtual memory and lock pages in memory to uh, avoid this means we can say that the low page life expectancy in SQL Server basically. Okay, this is the monitoring part. We will do that practical in performance tuning optimization class. Okay, next is about how can we check that this is very old. Now we are going for memory grant. Okay, so we can select this. Oh, so see, this is a hint basically. Okay, we are providing here to use mdot. This is not configured on the server level mdot. So just for this query, you're providing that use that mdot because we have a cross apply and all waiting for all the data. See, so granted 1 KB, 1 GB, I think. Okay, m.1 session ID 3, and this is a text. So this command we have get about 1 MB of memory to the from the SQL server, or we can set a buffer manager. And this is the plan for this query. Okay, like that we can pass here the query handler. Sorry, we can say pass here that query, and we can check that how much memory assigned to that query. Next is resource semaphore. No, now it is not required. N19 AW already deprecated. So basically AW is configuring the memory basically. Okay, address windowing extension from the SQL server side, but is not required now. Okay, we are not doing this changes. Okay, now next to reading the log. So we have sp read error log. So we can hit here to read the logs. But we can also check from the GUI side. This is a monitoring part basically. I think already shown you yesterday, I think. Okay, so you can see sp read error log. There's a parameter for 1 day, 2 day. We can also pass here parameter 1, and then we can see 1 day before. You can see here basically all the data in current log file basically. Okay, after restart. So we can see that server is started on this time after all log here in this file. Okay, current log file. Or I can show you from the GUI part also. How can we monitor the logs, server level logs, agent level logs, and job, yeah, database main logs. So see what are the all transaction happened on that server side till after the start till now. Okay, see the timing 11, sorry, 9:34 p.m. See the time is 10, I think 10, yeah, no, yeah, same, yeah, 10:15 p.m. So we get all the data here. That is what we have done. So we perform the backup and all. This is here. If you want to see the older one, so just click on the server, go to management, then we have a server logs, then we can see all the logs after system build. Okay, that is we have built a system on this day and we have all the data. It will change at the day of restart. Basically when you restart that, we create new archive older one or new one is current. If you restart, then time will be changed and the name will be changed. So you can see that current one, we can see this one. So we also see that from the command prompt and GUI side. GUI is like this. Yeah. If you want to see older one, so we can just uncheck this one and we can click on this. So before that, we can see 29 to say 26 and that because we started multiple times that day. So we have a couple of file on 26. See. So you can go get all the detail or message, any deadlocks or blockings or connection failure, anyone trying to connect from different network, different zone. So we will get here. See, authentication mode is mixed mode. That means SQL Server and window users can connect to the SQL Server. Then we have a agent log from here, then database log from here, and we can see also Windows log. Basically, Windows application that this window we can see from that extended sorry event viewer also for monitoring SQL Server and also event viewer. Okay, we'll get the same window like this. See, uh, uh, see Windows log application and hardware and all we can get here. See, and the current log is here. So we just make a filter here application at MS SQL Server, and then we can check all the MS SQL error log or information or any we can say that yeah, failure alerts and all. So there are two way we can monitor SQL Server and Windows logs and all. So we are here on the command. Okay, so question till now for monitoring part via command line. Then we can check here about the memory clerk. Okay, it will distributing all the memory to the resources. So it is monitoring. We have multiple matrix here, or we can say that we should check the value. See, memory type. Okay, and pages in Cabri, virtual memory. You can see here. All the name we've just filtered that as per our requirement. Okay, if required, but not I think not necessary to go in that more than 364, sorry, 634. So this is just a query basically for monitoring this one, and we for waiting task. So we can see here Windows scheduler, we can call that DMV basically. So we can just hit server, paste here. So this is a DMV OS scheduler, and we are finding the scheduler more greater than 255 basically. See the count and all. So basically, Windows Scheduler is not also required in very frequently. We just check that OS stats and other. We can see that different one is that this one waiting task. So count what how many count task is waiting and resources. Okay. And the last wait time or this time millisecond. So we create a report for this. So these all are DMVs basically system views. Okay, system dynamic views basically. Yeah, any question? Hello.
No, it's fine. Yeah.
Okay. So these are the weight types basically. See, wow. We can check distinct one also. Okay. So we can get accurate what are the weight types and all. Okay. And we have also a class for maintenance for performance tuning. So we can see all the weight type basically and what we have to check and what may need to be changed for that removing this weight type. Now we get a lock info here. Okay, for that instances. See this perf count. Just copy then and then hit here. See. So these are CTR type. Okay, counter type. Okay, counter name. Lock request per second on the instance level, and this is the value. Okay, means it till time it is logged. Next, not this one. This is plan cache and free single use cache. Okay, so we can use that free dbcc command. So this is for freeing the cache. Okay, so this is dbcc command. This is a part of performance tuning. Basically, when cache is full, so we can release the cache, or we can just restart the services if required, or for TMDB also. Get execution plan. So this is a query. Okay. Da, 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 da. Okay, so we are calling here that exe query and cache. This is a DMV. This is also DMV query plan and query text for checking all these things. So see the syntax DMV exe, that is executional file name basically, and we have a query plan and query text. So we need query text. We have to pass that query text here. Okay, and for plan is plan. Just we have it is easy to remember, but basically okay. I will share the very frequently used DMVs. I have already created the list and all. Oh, in. Where is in? Why it is in? Wrong. In KB. Okay, so we have to remove this, like this, or this. Now it's fine. Okay. It will select all the plan and plan cache here. See the text and all. What we have fired here, no? The size in KB and type of object is procedure, PROC procedure. Okay. T for table, V for view. Okay. And see the type of objects. Ad hoc query also here. This is ad hoc query from call from that. I think this is for extended events here. Okay, this is extended event calling. So these are the query which will monitor. See all the text here, which type of command fired here and matrix and all. Yeah, and the query size and KB, type of objects, and here's a query plan. We can check the query plan. Just we can click here. We can get that graphical design. See. You can keep the cursor and get that hint about that. This is cluster seek indexes, index seek, yeah. This is cluster index seek. This is basically query plan. Okay, so you can get a query plan of that SQL statement and all. like that. We see the query plan objects in that performance tuning classes. Okay, I'm not going in deep right now. Okay, just I'm showing how can you monitor that. So if you have a query, then we can fire that. We can check that query here, and we can check the plan how it is created. Okay, next this is our blocking sessions. So performance tuning to check that one. We can check that VLF here. Okay, let's see. Virtual file. Copy, and we check the virtual file of that database basically. Let's see the user database. Yeah, it is showing all basically. It is joined by master files. Okay, it is showing all the databases, VLF and all. See, we can pass here filter also. We can pass the database ID and then we can filter that data. So basically this is for report, so we can get all the database and byte read, byte write, a number of size. Okay, yeah, here see size in MB, that MDF file and all. Basically, this is written as a reports basically. Okay, we can just filter that and we can visualize in reports all the details and all. Next, about the estimated time query completion. So let's see here. This is from sys.exe request. I think I have shown all these things. Okay, in previous command. This is exe request basically. So we can customize this exe request as per our convenient, and we can use that. So here we have called session ID percentage completion is elapsed time, and yeah, in second. Okay, this is in milliseconds, so divided by 1000. And the command like backup, so backup start and yeah, start time, and restore we can also get that. So just here is that command. So we don't have anything here, so we are not getting this data. So we get table like this: session ID, percent completion, and completion time in second, and command that is backup or restore, whatever, because it's a filter on two things. Okay, command like backup and restore only. And this is for page buffer as part of performance. Let's see. Okay, go down. Oh, let's see like this. Yeah. So see the cache spaces count in memory. Yeah. For this database is like database name and page cache in count. Okay, so we can order by as per utilization, but is ordered by that cache count. Okay, let's see here. Yeah, see. So we can also modify this. We can use for a database ID.
So more
Mm,
the pages are cached, it is good.
yeah, good. No? Yeah, that is good. Best. So here it is for temp.db. So this is see here. This is for temp.db, not for user database. See. So if you modify some data and writing some data, fetching the data, so we'll get the user database here. I think user database should be on top rather than the system databases, because we are not hitting system databases from application side.
Any value here, like which is if it is less than this,
No, no. It is
nothing.
as big as it is best. If it is a user databases, means let's see any historical database. Let's see, you have a we can say that we have a report like let gold loan. Okay, so gold loan, let's say example of gold loan India info line. So I seen the databases. So in that there are two tables. There's historical table and one is a customer old customer data. The loan is closed. Okay, so we are not hitting that table or net databases basically. Two table in the same one databases. So we are not getting that cache memory, cache pages count, because you are not hitting that one. If you are hitting that, that is come from the disk to memory cache or embed buffer cache. So that depend on the heats. Okay, how much we are hitting the databases. Okay. Any question or you got our answer?
Yeah, it's fine.
Yeah, sorry. Okay, thank you. So it is about that cache count in pages basically. Okay, page count in cache. Okay. So next is about the buffer free and how it is used. So let's use by table and all. So we can see that table and that current size and free spaces. So this is also
So
part of
you will be sharing these queries later.
yes, yeah, yeah. I can see a stereo. This is
And
the
I
master
mean,
key.
this is a generic, or like is it prepared by you separately for?
Nay, this is generic basically. Some I have
Okay.
customized for my own basically. This is created very old basically. So that time there's a requirement from that
I
customer
mean, I
side.
mean, if we use this works in all versions and all
Yes,
that.
yes, all version, all environment. You get the same data.
It is not
Not enough.
specific to any.
No, no, no.
Uh,
Because DMV is global, na? Basically, if you install an instance, SQL Server instance, may not depend on version, not version depend on edition any. Okay, you can execute anywhere in the SQL Server environment,
yeah.
except that read-only servers. Okay, this is in replica basically. SQL Server replica. So you can get an error. You can get not get put whole matrix from there because data is in
Mm.
synchronized mode or recovery mode or standby mode. So you cannot get that data from that server. But in production server, you can get all the data. It will not throw an error if you execute this one. This is not an high IO intensive queries. This is simple reading from DMVs only. Okay, system DMVs. So now we are just going to monitor the tables of user databases. So you can see the list. Okay, the table name, the index name, and free byte here. See, it is about all the indexes. Okay, the user databases we can just pass here the table name, object name, and we can get that one. So you have not written a condition here basically. We have just made a join and from that sys.tables and indexes. Okay, so it is saying that this is a free space byte for this table. Okay, or this index. Okay, we don't have index, but this table. Okay, so we can write 400 byte in that table. Okay, till now, then it will claim a space from that disk.
So which query will tell about whether this index need to be rebuilt?
Yeah, I'm going just coming to that one. That is 25, 26 number. I am reaching there. Yeah. So this is what buffer, not, yeah. Index fragmentation. See, okay. This query will give you answer basically, but we don't have any index on server. I can get it from backend for the practical session. So it will show later, but yeah, let's try and keeping these, let's 10. Okay, leave it. Basically this value is more than 30 for revealed. Below that we can do a reorganize. I think already I've told in previous classes. Okay, so we don't have any indexes. That is highly fragmented all. Okay, so we are not getting any number here. Okay, so I will do one thing. I will do some mm, create tables and drop some data from that table. So it will fragmented. Means I will make data is fragmented, and then we can show in that performance tuning optimization query. Okay.
I
In
think
the
it should be there in adventure schema, no? Some indexes.
let's see, this. Let's try this one. If we got yeah, yeah. Thank you. So see here. Yeah, I've installed it for this only. Okay, see. So I have think this is after 10. Na? Okay, not any. So we focus on this is fragmented ever 100%. So we focus on this table, this index is cluster index, and this is a primary key. More fragmented. Okay, so we will just do one thing. Just we have to rebuild this index, or if we are getting more indexes on same table, then we have a command like we can rebuild whole table basically. But that is a bad practice because this is a high IO intensive. It will generate too much log blockings on the server. So we have to think according to the server performance to perform that maintenance activity. So I will just show you just one demo basically. We are not going in deep because we have a different class for performance tuning. So there's a command like alter index and index name. I'm not going on table level, okay? Because I have to specify this as 100 here. Okay, in this is a command line. Okay, alter index name. Okay, on the table name, we can write here with reveal, or we can say that direct revealed. This is a command. Next, we have multiple parameters. Okay, like fill factor. If we have syntax is wrong, fill factor. I think name is wrong. Fill factor like this. No, we can check from here. Fill factor. What is spelling? Fill factor. Let's see. SP configure. We can pass too many parameters inside that reveal to optimize this rebuild index query. Okay. We have not enabled. Okay, this is fill factor. Okay, same name. What is getting here? Fill factor, and then we have pass here rebuild with, sorry, and we can also be a facility for online. Okay, we can do this rebuild offline or online. Okay, so we have to just pass here on online on. Okay, this is a parameter basically.
What is the
Rebuild
use
with,
of fill factor?
yeah, I have told you there's a fill factor. How much we are filling the data pages means if we have a page, we have 100 rows, like your notebook. Okay, so how much we are filling that pages. If modification required, the modification got in different pages. So when you retrieve the data, it will take time to read the data from multiple pages. So if there is a frequency of modification more on the databases, then we set that fill factor that we are not going to fill that data pages 100%. We are filling 90% and 10% keeping free for the modifications. So the modified data not going to write on different pages basically. Okay,
And what is the optimum size for
8
index?
KB. No, index size means in KB. We can say that you
No,
are
not
asking for.
size, fill factor, optimum size.
Yeah, optimum size, that is not any hard coded or any best practice written in any book basically. This is depend on this application ki how much we are going to data modification done in that future or coming time basically. If we are thinking that we have less modification from the application side, like we can say that, and you have application CRM. So in CRM, we can just upload data and agent is calling. They are not modifying any data except one report. One report that is done by team lead or we can, yeah, TL or team lead, whatever they have. So that table can modify. So as per DBA, we have experienced that no one going to modify the data basically. Most of the table is read only mode, sorry, insert writing data only, not modifying the data. So we will keep that 100%. There is no more fragmentation because we are not deleting data after some time. That is as it when we have uploaded from Excel file or any note file or flat files. So it's totally depend on you to analyze that or ask developer how much we are data going to modify. Let's you can see that lab. Okay,
And what is
uh,
the default value if we don't
that is
specify?
100 full. You are going to
Okay,
full 8 KB pages.
okay.
Yeah, that is 8 KB. Okay, the page size is default 8 KB. Extend size is 64 KB. Okay, so I've already defined a study class. There are two type of extend, that is mixed or uniform. Uniform means same type of pages like table pages or index pages is uniform extend, or mixed extend means in that we have a table level pages or index level pages combined. So that is a mixed extend, and the total size of extend is maximum size is 64 KB, and a single unit of data pages size is only 8 KB. This is a smallest unit of data.
Okay.
So we can feel that why it is giving me an error factor. Okay, so you can pass it is 90 per, sorry, just click wrong. Yeah, here. So number 90, insert not. Okay, this is okay. Why it is fill factor? I think it will take in one name, maybe. Yeah, integer. So we can move this. Okay, so this is the syntax. So previously we don't have online option for revealing the indexes. Previously means before 2014 release. Okay, till 2012 we have to make this revealed online, and it is very IO intensive and making too much locking in on the table, because we are altering the basically table. So it will take a lock on the table, and the application go slow down, or we face the performance degradation issues. Okay, now we have a online, so it will not uh, create a blocking on the table. Okay, it will release we can say that it will do like we can say that partially lock, we can say that, uh, and it will not impact the performance of the databases. Okay, so now we have to just reduce this is 100%. Okay, just execute this one. Okay, we don't have permission on this table. Why? Alter index name on the table with rebuild syntax is right, but we don't have permission. Why? We are a sysadmin. Hmm, 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 this table. Okay, I think we don't pass that schema name. Okay, need to provide the schema name. What is this? Transaction history archive. Where is transaction history archive? Hmm, hmm. Let's find from here the schema name. Let's for that we have to provide a schema name, because we it is detecting default dbos schema. That's why. Okay, we don't have a schema here. Cluster index name and this. So table is transaction history. Okay. This one we have production schema. Okay, this is production schema. So we provide the production dot this. Okay, now we have to provide here production dot. Now it's okay. Let's parse this query. Now successful and execute. Yeah, this is successfully executed. Let's see it is defragmented or not. Else we have to rerun. Okay, but so now see we are not getting this one. This is defragmented. Okay. Yes, done. See, any question on this index fragmentation or rebuild?
So what is the minimum average fragmentation in percent, like for that we go for rebuild?
Yes,
30.
I have told many times this is 30%,
30. Okay.
30% and above we go for rebuild, else we go for reorg.
Reorg.
Yeah, we have a reorg. I think I have shown in maintenance plan here in SQL Server we yesterday. This one, this one, this one. We can create from here. If we do not know where to rebuild, which index need to rebuild, so we go on this place, this rebuild, select this one, and just we can pass. It is for all table on a databases, but this is very IO intensive because it will if you kill this transaction now, it will take roll back to same time basically. Let's see this example. If this job run for 15 minutes, okay, and you getting call from the application team, this is very server performance very slow. So then you are trying you're thinking that we have to just kill this job. So if you kill this job, it will take more next 15 minutes to roll back because it will recreating that index or fragmentation, and then transaction will roll back basically. So it is very hectic task for a DBA to do from that maintenance plan. Okay, so we just call the job and we create a statement and then we execute that one. Well, we'll show you just basically how can we do. Let's see adventure work. Here we can set max job. If you're providing that max degree of parallelism to this job, you can use, or else see keep online. It will avoid deadlock. Okay, advanced sorting you can use on temp DB for the best performance. Okay, and see here fragmentation greater than 30%. See, these are optional optimizing the index only, but you can use that, or we can say that if there's too much indexes, we can say that 80%. So we can just do this job is defragment that indexes which have 80% fragmentation above, and above means 80 to 100%. So we have to just modify these parameters as per our utilization of the servers and all. We also think about the server utilization before implementing this rebuild index from maintenance plan, because this is totally IO intensive, log generation, and you'll log the tables and all. So we will not select any statement from that table and all. Basically, this will totally degrade the performance of databases mainly. So this is the parameter we can set that. Okay. I think you understand about that data's fragmentation and defragmentation. Okay. So this is the value. Below that, we can go for reorganize. Okay. In There is difference between reorganize and rebuild. Rebuild will delete and recreate the indexes. Simple. Okay. But reorganize not deleting the index, just moving the space between that pages basically. This is simple difference between reorganize and rebuild indexes in SQL Server.
So in which scenario do we do rebuild and which one we do reorg?
Yes, below 30% fragmentation. See here, I have written here 10. Okay, see, go to the go down. Sorry, in here output. Now we have this index on this table. Okay, so we will go for reorg for these indexes.
Okay,
But
reorg is also online, no?
no, reorg is offline,
Offline.
not online. But it will not locking your table. There's a difference basically, because it's not
Okay.
deleting your index name. Because in alter command you are dropping this index name, index, and recreating with the same name in the backend.
Okay.
So that's why it will take occupied or lock on that this table, and then deleting that indexes and recreating the indexes. So it is a totally IO intensive. There's 3 or 4 tasks behind that query.
Okay, but if we are specifying online equal on, then it will not lock, right?
Yes, it will not lock. These are new features basically. It will generate a snapshot of this replication index simply in memory. This is for online SQL Server generate a snapshot of this index first, and then start working on this defragmentation part. So user can use this index from memory, basically a snapshot, and it will not take a lock. After deleting this, a snapshot also deleted, creating this alter index activity. So this is a benefit of online rebuild basically. In offline, we will wait for that completion of this activity task and all. Till time it will take a lock and doing their alter activities on the database level, dropping and recreating the same indexes with the same name. Yeah, that's it for we can say that rebuild index and reorganization. Any further question? Any other doubts on rebuilding? This is a part of performance tuning. So I've just done here basically, but we'll see again in that performance tuning part. Okay. This is the first step. Basically, every DBS here, I'm going to create the indexes, and it will solve my problem basically. But nay, but after that, we have too many things to analyze and monitor on the server side. And next is let's go to that long running query by IO. We have seen from GUI side, but we can see also from that query side. Okay, this is we get a historical data, then we have to go inside that query and look into that. This is you can pass DBID or yeah, it's taking from this. Okay, let's see. So not going for 100, let's 10. Okay, so we don't have long running queries here, so we are not getting that one. Okay, and next is long running by duration. So you can also check how long could the query is running on the database server. Sorry. Oh. Next is okay. Let's select this one. This is from query stats and query text. Yeah, about the query. Okay. So this is we have an average CPU duration, a number of count by this query, how much time this query is executed on the system, average duration, total elapsed time, worker time, okay, last execution. These are things we get the query type of this object. This is query what it is used. That is foreign key, primary key, procedure, table, view, whatever you can see here, the database name and all. So it is very helpful query basically for performance tuning point of view. See. Okay, and next is missing indexes. So we have rebuilded indexes as that is exist on the server. This is highly fragmented, but we have created a hash table. Okay, sorry, heap table. Sorry, not hash, heap table. So heap table is the table which has no indexes, known as heap table. Basically, simple definition. So we have a table, history table, transaction table, and we are reading data more from the transaction table, but it is going for table scan. So yeah, table scan or index scan, and we are getting data very slow. We can say that. So we need to find that missing indexes and need to create on which column we are getting more hit from that application server. So we get that we can get here the uh, user seek how many times. Okay, then it is a scan or seek, then the database name, that is table name, then the column name on which we have to create a indexes. That is a missing column basically. If we have using where clause like employee name and employee date of joining, so we get the date the column name here. So we just create an index on this table using this column name. Yeah, so this is about the missing indexes. So this is about more about, we can say that we have seen this procedure first. Yeah, we have seen this procedure. Okay, so I think I have touched all the important topics for monitoring, regular monitoring as well as performance tuning monitoring. Okay, if you have question, then we can do a question Q&A session, and else we can wrap this call. Yeah, Manu and Gopal.
Nothing from me today. I need to complete the pending things.
Yes, so
Okay.
for yeah, I'm just stopping this sharing, and we can say that recording, and we'll discuss about today, tomorrow, and